So today we are joined by Jeanette and Jens Carlsson, from the co-founders of BioID, and they're looking at environmental DNA in aquatic environments and an early detection warning systems. I'm saying it all jumbled up for aquaculture. So thank you very much for joining me today.
Thank you. Thanks for having us.
It's great to have you online with us. So I'm going to jump straight in, and I'm wondering if you can tell me a bit more about BioID and the work that you do.
Well, BioID was funded a long time ago. Well, not long time, 2013, I believe. And it was set up to look at deep sea studies in the Black Sea, working for Gazprom. But it was basically put to rest for quite a while. But then we started working with environmental DNA, which you're probably going to ask me about.
I am indeed.
And that basically kicked off. It turns out to be a very efficient technique to find things that you're looking for that are very difficult to look for. So we call it really the needle in the haystack tool. So if you want to find a needle, your environmental DNA would be the way to go.
The way to do it, yeah. And for someone who doesn't know what environmental DNA is or has never heard about it before, how would you describe it?
I actually think you have heard about it, because everybody heard about the COVID tests that are being done as we speak. So what happens there is that you're looking for parts of the virus in the tissue sample, the swab that you give away. And they're doing something called a quantitative PCR, and that allows you to detect the presence of COVID. Now, the methods that we are using, we're not using swabs from humans, of course, but we're using water samples. And in the water, there are traces of the DNA, or RNA in the case of COVID, traces of DNA and RNA in the water. And that is exactly what we pick up. So we can pick up a water sample, then we can say what organisms are in this water sample and to what concentration. So you've probably heard about environmental DNA, but it's in a different form.
Yeah, that's a really great way to describe it, because we've been hearing a lot about PCRs and all these things over the last while.
Yeah, no, that's the only good thing COVID brought with it.
Yeah, I know.
Real-time PCR.
Yeah, it's made a scientist out of everybody. Thank you very much. And in terms of the work you're doing, so how would it benefit the Irish aquaculture sector?
Well, if you look now what's happening out there, we have diseases coming in. That's just normal in any aquaculture facility. And they're in the background. When the conditions are right, they tend to strike, to go up in quantity, and then they're starting to affect the fish. Now, what we're trying to look at here is using water samples. And the water samples could be collected from further out in the bay, for instance, and see if there's toxic algae coming in or diseases coming in.
Right, yeah.
We can measure the level of different diseases, and that would allow you then to come up with mitigation strategies earlier than if you have to wait for the fish to actually show signs of disease, or you have to try to predict it, say you stop feeding because the temperature levels have reached this level and so on. So then you stop feeding and then you lose growth. If we can avoid that by knowing the concentrations of all the pathogens in the water, then that would assist the aquaculture industry.
So you're kind of giving people the opportunity for early intervention, really.
Exactly.
Yeah. No, it's really interesting, and it makes sense, like why you might as well solve the problem before it's even developed. So it's a great way to do it.
You can see it as a radar. You know something is out there, but you don't know when, how much, or what, when, where it's coming.
Yeah, because they're kind of invisible problems. Like, it's not as if you can watch them creeping in or anything like that. So you're getting ahead of it. Yeah, it is like a radar system, isn't it? Yeah, fantastic. So and what stage of development is all of that innovation at now?
Well, the environmental DNA aspects of them, they are fully operational now. So one can go out and do it commercially. We have been doing that for rare species in aquaculture, in freshwater, for instance. So it's already there. Now, what needs to be done better or more of is obviously development. Everything can be done better than we're doing it now. So the idea is you're trying to miniaturize these things, to have them in automated stations. So there's less and less user intervention. And at this stage, you have to send the sample away still to a lab. But we're trying to bring the lab out to the farm, and the lab would run itself. That's what the future holds. And compare that now, when you have to send in, you have to wait until you have disease signs. You take tissue samples or whole fish and send them in for analysis. That takes a little bit of time, but we're trying to reduce that time to live more in a real-time environment.
Which is fantastic. It seems like just a really kind of practical solution, and especially if and would it be a case that someone could do this themselves? Like, will this? Yeah.
The idea is that, so basically, we don't have the technique here now, so I shouldn't promise too much, but I don't think we're too far away from it. Basically, litmus paper. So you dip a piece of paper into a water sample, and that should tell you what concentration of any pathogen you have in there.
Yeah, it's really interesting. And I think you kind of touched off it a minute ago when you were saying that your solution is sort of real time and more practical, but how does it compare to other solutions on the market?
On the market now for disease diagnostics, I think you simply have to wait until you see any signs of the disease, or you have to have a monitoring program that you constantly sample or ever so often sample. There are models as well that can say you're very likely to have disease during this time of the year if you have these conditions, etc. But they're all trying to predict. Well, some of the models are trying to predict, but otherwise you have to wait for it to basically happen to see it.
You're really sort of taking the guesswork out of it.
Yeah.
No, it's fantastic. And then can I ask, so you're working on that now, so what are the next steps in terms of your research now, or when do you think we'll be able to see this?
Well, we can already do this, if whoever would be willing to even, send us samples now and we can process them. The idea is just to speed up a bit, and I would hope that within the year.
Fantastic.
Next year. Well, we're very close to 6 years ending. So hopefully by the end of next year.
There should be other products.
But there will be a series of them, to try.
I'm not going to make you commit to anything just yet, so don't worry. But it's really interesting that's coming online so quickly as well. It's fantastic.
Just look at COVID. COVID came and all of a sudden we had a vaccine. And now we have multiple vaccines.
And antigen testing.
We have antigen testing, we have antibody testing, we have the quick PCR test, and we have the PCR test. So all of these different diagnostic techniques can be incorporated into early warning systems as well. So we are actually benefiting an awful lot of what's being invented on the COVID side.
And you never think of that kind of transfer of knowledge like that there is people actually benefiting from the kind of scientific advances that we've made in that space of time. But it's fascinating. Brilliant. I'm really interested now to see how this progresses, and I think there probably are a lot of other applications outside of aquaculture as well. Yeah,
there are multiple applications, but I think we need to restrict us a bit.
Focus on one thing at the moment. That's brilliant. And I was just wondering if anyone wanted to find out more about the work you're doing, where do they go?
Well, right now we're working on our webpage, but they can reach us through email at BioID info@gmail.com.
Fantastic. Actually, I can put that up on.
We would love to hear from people. Ideas or whatever.
That's great. I'll share that on the IATiP website then, so anyone who's watching this can find those details there.
Sounds great. Thank you.
It was lovely talking to you this afternoon. Thank you very much for joining me and just giving me a kind of a whistle-stop tour of the company and and everything you're doing as well. It's brilliant.